Hello guys, I'll be doing the chemistry video for this week. Question number one says, which of the following has a stable electron arrangement? When they say stable electron, that means it's a noble gas. So you should know this by memory, but in case, just look at the periodic table in front of you in your exam and just choose the elements that are like in the last group, since they are noble gases. So they have a stable electron arrangement. Not the properties of a noble gas. So noble gases are not reactive. Okay, they are not reactive. They're stable, remember? Okay? They are monoatomic since they don't react to the other elements. They are inert, that means they are stable, like they don't react. They are in the last group, and this is wrong. Their melting points don't decrease down the group. Their melting points and boiling points, they increase as the atomic number increases, because when you go down the group the atomic number will increase, right? So when the atomic number increases, the melting point and boiling point will increase, not decrease. So these two are wrong. Atoms is unreactive monoatomic gas, so we can know that it's a noble gas by this info, and it has an atomic number of 2. Without using this information, we can just see the one that has an atomic number of 2, it's instantly helium. Just look at the periodic table, the second element. Low potential energy, just memorize this. Low potential energy means it's stable. Okay? High potential energy means it is unstable. Okay? It's actually common sense, like low energy or like low potential energy, it means it will be more stable, it's a bit more calm. Ion formation, so it's negative, okay, and positive. Negative ion means anion. An anion means it's negative, that means that you have electrons. And positive, it means it's a cation, so that means that you removed the electrons, right? Remove the electrons, let's put it as E minus, and you added electrons here. Okay, when you add an electron, that means when it's negative, energy is released, that means it's exothermic. Now think of it in this way. When you want to remove an electron, you need energy to remove this electron. Okay? So this energy means you have to input energy into the system. Since you have to input this energy, that means it absorbs energy, therefore making the system endothermic, or energy absorption, to make it positive, to remove the electrons. Okay, I will just repeat it in one last time. When you need to remove an electron, when you remove the electron, okay, you need energy. So energy is absorbed, energy is input into the system, okay, to remove this electron. And then to add an electron, it's exothermic, you release the energy. It's the other way around. Now, okay, electrons in an isolated atom. Electrons are not found in the nucleus. Electrons don't move in circular orbits, they move in random directions. Okay, there's no specific pattern they revolve around, and they do not vibrate back and forth in fixed positions. They don't go in fixed positions, they go in all directions, all randomly. You see this zigzag scribbly thing? That's how the electrons move. They don't revolve in a nice pattern. No, they don't do that. So they move randomly around the nucleus, not in the nucleus, around, so surrounding. And look at this keyword, randomly. Isotopes, they have okay, what's the thing about isotopes? Isotopes, you just need to know it, that it's the same element, but what's different is the different neutrons. So if there's different neutrons, that means that there's different different nucleons, because what are nucleons? Nucleons are protons plus neutrons, right? So since the neutrons changes, this will make the nucleons change. So they will have different nucleons, different mass number. Since the mass number, which is represented by the symbol A, it's equal to nucleons, okay? So the mass number will change, nucleons will change, okay? Same number of neutrons? No, neutrons will change. Same number of protons is true. They will have the same number of they will have the same atomic number. They will have the same protons. Different mass number is true, and same atomic number. If they have the same protons, that means they have the same atomic number. These are the same thing. And different mass number is true. Elements between group 2 and 13. Columns means group, by the way. If you hear me say groups, that means column in the periodic table. 2 and 13, they are called transition metals. We have group 1, we have 2, and then we have like these transition metals. And then we have 3 or 13, and then 4 or 14, and then so on. All the way to 8 or 18. Okay, so these are transition metals. They're between groups 2 and 3 or 2 and 13. Same thing. And one fun fact about them is that they form colored compounds and they have more than one charged ion. Okay, so they just added this as a fun fact. It's better to know them. It's better to be safe than sorry. So just memorize that they form colored compounds and more than one charged ion. But just know that it's between groups 2 and 13. Okay. NaCl, sodium chloride, is a very stable ionic crystal. Although it's not made up of noble gases, it is a stable ionic crystal since Na is alkali, right? So it's stable, and it's a crystal. Since it's an ionic compound, it's a crystal. It's built up of charged particles, so Na plus and Cl minus. These are the charged particles that have a noble gas configuration. Sodium will lose one electron while chlorine will gain. You can see that sodium, it's positive. That means it lost an electron and it donated it to Cl, or it gave it to Cl. So Cl became negative. This is more to be memorized, but it's also common sense. Okay, now this question. It's easy, but like if you find it a bit difficult, just memorize. So alkali metals are soft and malleable. Soft because it's easy to touch, like it's smooth and okay, soft is a universal term. And malleable, if you don't know what it means it's easy to pound. Okay, it's easy to like spread like this. That's why it's soft too, since you can hammer it down very easily, or you can pound it down quite easily. Since they're in group 1, they form +1 ions, and alkali metals are good conductors of heat and electricity, as they are metals. It's right there in the name. Heat and electricity, they're metals, are conductors. These are natural properties. Electrical conductivity of metals is caused by the presence of loose electrons in the crystal lattice that are extremely mobile. So, when we say conductivity, Conductivity, what is it related to? It's related to like heat, electricity, like electronics and stuff like that. And usually in electrical stuff, it refers to the flow of electrons. So the flow of electrons, okay? So what makes metals conductors? It's because they have loose electrons. Electrons which are ready to move. They are ready to flawlessly move around the metals. That's why they are extremely mobile. They move a lot and they are located in the crystal lattice. So the conductivity of metals is caused by the presence of loose electrons. Alkali metals are very reactive and they form very stable compounds. An example of a stable compound is NaCl, which was just discussed. It's just discussed. It's stable. We said it's stable, and Na is an alkali metal, and they are very reactive. For example, if I put sodium and I put it with air, or I put it with water, it will react vigorously. Okay, so there will be an explosion. It will even react even faster if you put it in water. That's why these types of elements, or these elements that are in group 1, they're not stored in just plain air, or they're not stored in water. They're stored in mineral oil. So they're put in this mineral oil so they can be preserved, as these metals do not react with the oil. So they're not stored in air, but they're stored in oil, since they're very reactive. An ionic bond is formed when an electron of an atom is transferred permanently to another atom. Let's take NaCl, the most famous one. NaCl, it's Na plus Cl minus. It's an ionic bond because Na donated one of its electrons to Cl. Therefore, Na became positive and Cl became negative, since it gained one electron and Na lose an electron. Resulting ions attract each other, so energy is released. You just know that since Na and Cl, they attract each other, they're gonna lose energy. Okay, so it's exothermic. Just memorize this, no need to complicate yourself. Just know that when the ions attract each other, so ionic compounds, they lead to energy being released. Okay, a stable crystal is produced, leading to a decrease in total potential energy. So since energy decreases, it's the same thing as saying that the potential energy will decrease. So forming ions decreases the energy, potential energy. Okay, just know this, memorize it. Letter A represents mass number, to be memorized, and Z represents atomic number, also to be memorized. Now, this is A, and this is the Z. So A is the mass number, or the nucleons, and Z is the atomic number, or protons. Now, we said that 35 is the atomic number, which makes it the number of protons. And then they asked for the neutrons and electrons. Okay, the number of protons will be the same as the number of electrons in a stable. Okay, here they didn't mention that it lost an electron or it gained an electron, so we consider bromine to be, in this case, stable. Not stable. We consider it to be neutral. Therefore, making it like it didn't gain any electrons. So the number of protons will be the same as the electrons. So if 35 is protons, and 35 will be electrons. And the neutrons, since this is nucleons and this is protons, and the nucleons, or mass number, is equal to protons plus electrons. Protons can be represented by H plus, by the way. Then it's protons plus electrons then to find, not electrons, I'm sorry, silly mistake, since nucleons is protons plus neutrons. It's a silly mistake, my bad, I knew something was bad. Nucleon is protons plus neutrons. That means that the neutrons is the nucleons minus the protons. So what's the nucleons? 80. What's the protons? 35. So what's the neutrons? It's gonna be 45. Okay? Sorry for the silly mistake. It's just this rule. I knew something was up. Okay. Here we have, okay, neutrons, protons, electrons. Neutrons, what did we say? It's the nucleons or the mass number minus the protons. Okay? It's equal to the neutrons. So what's the mass number? It's 35. Minus the protons, which is 17, you will get 18. Protons is just the atomic number, which is down, which is 17. And then the electrons. What did we say about the electrons? It's the same as the proton. So you would say 17, but one thing here, it's negative. So it's 17 electrons plus the fact that it gained an electron. Why do we say gained an electron? Since it's a negative ion, it's an anion. So it gained an electron. So 17 electrons plus 1 electron makes it 18 electrons. Neutrons, we said it's A minus H plus. So 27 minus 13 is 14. Protons is just atomic number, and the electrons is the protons, which is 13. But it's 3 plus. That means it lost 3 electrons, okay? 3 plus, it means it lost electrons. How many electrons did it lose? Did it lose 3? So 13 minus 3, which is 10. Now, Na. We said that neutrons is 23 minus 11, or mass number minus atomic number. So 23 minus 11 is 12. And the protons is just the atomic number. And the electrons is 12. How many electrons did it lose or gain? It lost 1 electron. So it's just positive. So it's basically like 1 plus. So 1 plus means it lost 1 electron. So 12 minus. 11. It's not 12, I mean. 12 is the neutrons. Protons, 11, which is here. 11 minus 1. Since it lost 1 electron, it becomes 10, okay? And then the neutrons, we said it's 32 minus 16, we get 16. And the protons is just the atomic number, okay? And then here it's gained 2 electrons. 2 minus means it gained 2 electrons. So 16 plus 2 makes it 18. Represents atoms. In this case, you would consider atoms. Here they would be neutral. So the protons, the amount of protons, remember H plus means protons. The protons will be equal to the electrons. So here we have 1 proton, 1 electron. So this is an atom. Here we have 1 proton, 1 electron. This is atom. Here we have 1 proton, 0 electron. So this is not an atom. Here we have 1 proton and 2 electrons. This is not an atom. And we have 2 protons and 2 electrons. So this is an atom. So the atoms are A, B, and E. Now, what is C? C has more protons than electrons, okay? More protons than electrons makes it positive. Therefore, it's a positive ion. And less protons than electrons, so 1 proton and 2 electrons, makes it a negative ion. Number of protons is atomic number, represented by symbol Z. And they want the atomic number 2. When we say atomic number 2, that means we want the protons, which is H plus, to be equal to 2. Here we have 1 proton. Here we have 2 protons. You see, you have to look at it clearly. You have to zoom in the exam to make sure you don't do any mistakes. You have 2 protons, which is correct. Here you have 1 proton, wrong. And here you have 1 proton. So it's this one. Done with 2 protons. Mass number is protons and neutrons. What else is protons plus neutrons? Nucleons. Therefore, making nucleons the same as as mass number, I mean. They want an atom with atomic symbol, this one. The number that's down is the atomic number, making the protons equal to 1. And the top number is the nucleons, or the mass number. Mass number is A, and here's Z. A, which is equal to the nucleons, is gonna be equal to 2. Now, what did we say about the neutrons? Neutrons is the nucleons minus the atomic number. Okay, so A minus Z, right? Or A minus H plus is equal to the neutrons. So basically, if it's 2 minus 1, that means there's 1 neutron. So we need to find an atom with 1 proton and 1 neutron. Okay? So, this one has 1 proton and 1 electron. So it's wrong. This one has 1 proton and 1 neutron. Correct. We don't care what the electrons are. Okay? Here there's 0 neutrons, so it's wrong. Okay? Here there's 2 neutrons, 1 proton. It's wrong. We said 1 of each. And here there's 2 protons, 1 neutron. Wrong. We want 1 of each. So this is the correct one. Isotopes, this is the correct exact definition. Isotopes are atoms of the same element, and they have the same atomic number, so same proton, but different mass number, or different mass number, or different nucleons. They want an isotope of hydrogen. What does hydrogen have? Hydrogen is proton is 1. Aslan, they already gave it to you here. Okay, so you want an atom with 1 proton exactly. We don't care about the number of neutrons, and the reason for this is because they said isotope. If they wanted a specific isotope, like deuterium or tritium or hydrogen 1, if they wanted a specific amount, if they wanted a specific isotope, then we have to look out for the number of neutrons. But here they said any isotope, so we just need to look at an atom with 1 proton. This has 1 proton. This has 2 protons actually, so it's wrong. This has 1 proton and 1 neutron. We don't care about the neutrons. And this has 1 neutron but 0 protons, so it's wrong. So it's this image and this image. The images with 1 proton and 1 proton exactly. Okay, in the periodic table, carbon is to the left side of nitrogen. The atomic number of carbon is 6. What's the atomic number of nitrogen? Okay, atomic number increases, so atomic number, or H plus, or Z, it increases as the from the left to right. So as you go like this, the atomic number will increase. Okay, so if carbon is to the left of nitrogen, so this is carbon and then this is nitrogen, like this, and carbon is 6, then nitrogen is gonna be 1 more, so it's gonna be 7. This is a group. We said a group is a column, and is a period. So the period is a row. So basically, according to the previous question, the atomic number will increase as we go from the row or the period from left to right. In the periodic table, metals are found to the left while non-metals are found to the right. So we have, okay, I'm trying to draw the periodic table as best as I can. Okay, basically here we have the metals except for hydrogen, and then here we have the non-metals. Okay, metals are to the left while non-metals are to the right. Okay, here we have noble gases. In noble gases, as you go down the group, the atomic number, what atomic number? The boiling point or the melting point will increase. Okay, so down the group, since atomic number increases, or down the group, or increase the atomic number, it's better to use increase atomic number. Okay, it means it's an increase in boiling point. You don't need to memorize the exact boiling points, you just need to follow a specific pattern. This is greater than this is greater than this, greater than this, so the number after is greater than the number before. Okay, since the boiling point increases. Now here we have the same thing, boiling point and melting point. Boiling point and melting point have the same applications. They increase down the group for noble gases only, or some other groups, but like specifically for the noble gases, as you increase the atomic number or as you go down the group, the melting points and boiling point will subsequently increase. There's no specific memorization, it's just a pattern following. Now you have alkali. Alkali is the opposite of noble gases. We said that noble gases, they increase down the group, or like the noble gases, as you go down the group, or aka like you increase the number of protons or the atomic number, the melting point and boiling point will increase. It's the inverse, it's the opposite for the alkali. As you go down the group, or as the atomic number increases, the melting point and boiling point will decrease. So for the lowest atomic number, you choose the highest boiling point. It's the same thing for the melting point. It goes lower, يعني, while this, يعني, you get what I mean. It's the inverse for the melting point and boiling point. So for noble gases, as you go down the group, or as you increase the atomic number, increase MP or BP. For alkali, as you go down the group or increase the Z or the atomic number, you will decrease the melting point or the boiling point. Okay, this must be memorized. There is no specific memorization, it's just a pattern following. This one, you have to memorize it. When there's lithium cations reacting, that means it makes a red flame. When it's sodium ions, it produces a yellow flame, and when it's potassium ions, it forms like a purple, like a lilac color. Okay, it's to be memorized. Okay, lithium red, sodium yellow orange, and potassium is purple lilac. There's no other way to do this other than memorizing. They're asking for the atomic number. What is atomic number? Atomic number is protons, so just put 17. Okay, so Z, which is the atomic number, is equal to H plus, which is protons. Protons are represented by the symbol H plus, if you're a bit lost. Okay, mass number. What did we say about mass number? It's protons, or the Z, plus the neutrons. And what is this? This is the mass number, A, or it's also known as nucleons. So you just add 11 plus 20 plus 12 and you get 23. And they're asking for the nucleons. What was nucleons? Nucleons was the mass number. And what is mass number? What's the symbol for mass number? It's A. So that's it. Thank you guys, and good luck.